Hello student, welcome back to lecture series on Fourier transform. Already I explained plenty of the video based on the Fourier transform, Fourier sine transform, inverse Fourier transform, inverse Fourier sine transform, and some of the example based on the Fourier and sine transform. Okay, so in our today's video I'm gonna explain to you all one of the example which based on the Fourier sine transform. Okay, and this one is the example which is important for your Sppu question paper for 4 marks. Okay, it is one of the easy example. Just we have to figure it out here which one of the result we have to apply in order to solve this question. Okay, so let's get dive into today's solution. Okay, we solve this question, but if you want similar videos like this today's video, guys, check in my playlist. You will get the all my playlist available there. Okay, yes, let's get dive into our today's solution. I will explain to you all how the solution it is coming. Okay, now see that here if you get the question, if you get this question in your question paper, how can you identify whether to apply Fourier transform or to apply Fourier sine transform or to apply Fourier cosine transform? Okay, so there are some tricks here that we can conclude that we have to apply such a type of the transform. Okay, now as we know that whenever we have integrand 0 to infinity, which is 0 to infinity, then we know that it is possible to apply Fourier sine transform or Fourier cosine transform. About Fourier transform, we need minus infinity to infinity integral. Okay, yes, but we have 0 to infinity as an integral here, so we apply Fourier sine transform or Fourier cosine transform. Okay, so this one is the first trick that we remember. If integral it is from 0 to infinity, we apply Fourier sine transform or cosine transform. Okay, now we go for the next. When we have sine lambda x, okay, as we know that Fourier sine transform can define as sine x here. I already explained the formula for Fourier sine transform. Okay, yes, so Fourier sine transform contain the value for sine lambda x. Okay, and Fourier cosine transform contain the value for cos lambda x. Okay, so here we have to define. Okay, here we have to define this one is which is equal to here between this. Okay, yes, so here we have to define Fourier sine transform, as we have sine lambda x present and 0 to infinity it is the limit given. Okay, so we apply Fourier sine transform. Yes, so what is the formula for Fourier sine transform that I explained in my previous lecture? Okay, let me write formula. Fourier sine transform. Okay, Fourier sine transform it defined as capital F suffix s. Okay, we define Fourier sine transform in this way. Okay, capital F suffix s of s. Okay, so we write this one as a 0 to infinity f of x sine sx dx. Okay, now see that this one is our given formula for Fourier transform. Okay, yes, but now as we can observe, instead of a lambda we taken s here. Okay, that means these are the just variable. Okay, don't get confused about this variable. These are the just variable we consider here under sine. Okay, so I use the formula for es. Okay, so if you have the example in the form of a lambda, replace lambda as es. Okay, replace s as a lambda, so we get the formula f es capital F suffix s of lambda. Okay, Fourier sine over lambda, we write a 0 to infinity f of x. We cannot change that f of x. Okay, as we have integral. Okay, dx here. Okay, so we keep f of x as it is, sine lambda x. Okay, dx. So these are the same formulas. Just it is the replacement of es. Instead of es is the lambda. Okay, yes, similarly here. Now we are going to solve this one further. Okay, f s of a lambda which is equal to 0 to infinity f of x sine lambda x dx. Okay, yes, we are going to solve this one. Now compare this one with this one. Okay, compare this both of the value. Okay, now we can see that 0 to infinity it is there, f of x it is there, sine lambda x it is there, and dx it is there. So we can conclude here, we can conclude you have capital F of lambda, which is a e raised to minus lambda after comparison of these two results. Okay, so I'm going to write capital F S of lambda, which is equal to e raised to minus lambda. Okay, this one is our given Fourier transform. Okay, this one is our given Fourier transform. Now we want the integral. Okay, we want the integral. Now see that this one is a Fourier transform. Okay, so we want the integral. That means we have to find out the value for f of x. Okay, this f of x define as the integral. Okay, integral for our given transform. Okay, Fourier transform. Okay, so what we have to find? We have to find that small f of x here. Okay, now see that how I'm going to find the small f of x. Okay, small f of x, it represent integral. Okay, integral equation. That means if you want to find small f of x, what we are going to apply here? We are going to apply inverse Fourier sine transform. Inverse Fourier sine transform. We are going to apply inverse Fourier sine transform. Okay, yes. So in order to apply inverse Fourier sine transform, we know that the standard formula for inverse Fourier sine transform, which is the f of x, which is equal to 2 by pi, f of x which is equal to 2 by pi 0 to infinity capital F suffix s, okay, over lambda. We are taking the value in the form of a lambda here. Okay, so in our previous result I explained in the form of s. Okay, sine lambda x, okay, ds here. Okay, as we have Fourier transform present here, so we take its integration with respect to ds. Okay, yes. Now those values are unknown here. Okay, we are going to find. So what we have here, f of x, it is unknown here. We are going to find this value, but we know that the Fourier transform f s of a lambda, it is e raised to minus lambda sine lambda x dx. Okay, yes, just go for the replacement of value f of x, which is equal to 2 by pi, okay, 2 by pi 0 to infinity. Okay, f s of lambda is e raised to minus lambda. Okay, f s of lambda is e raised to minus lambda sine lambda x ds. Okay, sine lambda x ds here. Okay, yes. So I already explained some of the formulas here. Okay, in my previous lecture I explained some of the formulas for solving such an integral. Okay, yes. So which is a form of, now see that I'm going to show you all here that formula I already explained in my previous lecture. Okay, so as we have e raised to minus lambda into sine lambda x. Okay, so it represent e raised to x sine bx dx. Okay, e raised to x sine bx dx. Okay, now see that this one is similar like this one. Okay, so what we are going to do, we are going to replace, we are going to replace the formula over here. Okay, let me write this formula again, the formula which I am going to apply here. Okay, so integration of e raised to ax sine bx dx. Okay, sine bx dx. This one is the integral we are going to apply here, e raised to x sine bx dx. That is the standard formula I explained already in my previous lecture. Okay, yes, e raised to, we write this formula as a e raised to x upon a square plus b square. Okay, e raised to x upon a square plus b square, a sine bx, as we have sine here present, take a sine bx first. Okay, yes, and the cos we have to consider it is the negative. Okay, minus b cos, okay, minus b cos bx. Okay, this one is our given formula. Okay, that formula I'm going to apply it here. Okay, try to compare the terms, now see that e raised to ax, instead of x we have lambda, so I'm going to convert this step. Okay, 2 by pi, keep it on hold for few minutes, we go for solving this integral. Okay, so replace these values here. So see that guys, we have to compare this integration with this one. Okay, that means e raised to minus lambda sine lambda x d lambda here. Okay, this one is a d lambda, as we are replacing lambda, so yes can be replaced at d lambda. Okay, yes, so make sure this one. Okay, yes, so we can see that e raised to x sine bx dx, so this one is d lambda, this one is a dx. Okay, so we have to compare their integral also. Okay, so that means d lambda which is equal to dx, that means lambda which is equal to x. Okay, that means I got the value for x and lambda both are equal. Okay, Now a raised to ax, that means e raised to minus lambda, means we got the value for a which is a minus 1, okay, a which is a minus 1, sine bx dx, that means sine bx, x we, instead of x we have lambda here, instead of x we have lambda, okay, that means dx, and this one is a d lambda. So instead of x we have this x we have, okay, this x we have lambda here. So what we are going to do, we are going to consider the value for b. So bx means lambda x, okay, so that means value for b which is x here. Don't get confused, it is little confusing to consider the variable for this integration, okay. So see that this one is a dx, this one is a d lambda, okay. So this one is integration with respect to d lambda, and this one is integration of a dx. So obviously x which is equal to lambda, obviously it is coming. A which is a minus 1, it is coming. Now it is only the confusion value for b, how it is a x coming, okay, value for b, how it is a x, okay. So now see that I will explain to you all the value for b again, how it is x, okay. So sine bx and sine lambda x, okay, d lambda, sine bx dx, sine lambda x d lambda. So we can see that lambda d lambda, it is a similar variable here for d integral, okay, and bx dx, it is a similar variable. So we consider b which is equal to here x, okay. What is the value for b which is a x here? So I got the value for b x lambda and a minus 1. Replace all these values in this result. So e raised to ax means e raised to x. What is the value for a which is a minus 1, okay. So minus 1, a value for a which is a minus 1 here, okay, and x, what is the value for x we have here? Lambda, minus 1 into lambda, okay, yes, e raised to minus 1 into lambda divided by a square plus b square, minus 1 square plus b square. B square means what is the value for b we have here? X, okay, minus 1 square plus x square, okay, minus 1 square plus x square here, okay. So this one is the first part here. Under integration we write a is a minus 1, okay, it is a minus 1, which multiplied by sine bx, okay. So we want the value for sine bx. So what is the value for bx? And x is a lambda, okay, that means we write sine x lambda, okay, we write sine x lambda. Now see that I'm going to write it again, okay. So a is a minus 1, sine as it is bx. What is the value for b which is a ax, and what is the value for x which is a lambda? So sine x lambda here, okay, yes, minus, okay, keep minus as it is here. What is the value for b we have here? B it is here as a x, write down b as a x, okay. So value for b which is x here, so it become minus x, okay, and cos bx, okay, cos, now we want the value for b it is a x here, okay. So cos x, and x it is here lambda, cos x lambda, okay. This one is a complete part for this integration, okay. Now see that it is quite confusion here for b which is equal to x. So clear that confusion, guys. So once you clear this confusion, you can solve this one easily, okay. This question for 4 marks, okay, which is came for 4 marks in your Sppu question paper. Yes, now we go for solving further. Replace this value instead of this integral, okay, and 2 by pi take it here, then we solve f of x, okay. So I'm going to write f of x as a 2 by pi outside here under bracket, okay. This integration gives us this value, that means e raised to minus lambda upon minus 1 square, it is 1, plus x square, minus 1 square, it is 1, plus x square under bracket minus 1 into sine x lambda, means minus sine x lambda, okay, minus sine x lambda minus x cos x lambda, x cos x lambda, bracket complete, entire bracket complete, okay. So we take integral over 0 to infinity here, okay. Yes, as we have limit for our integral 0 to infinity, so we have to apply after solving this result, okay. So now see that first of all we are going to put infinity into this entire step, as we are taking integration over d lambda, so we have to replace, what we have to replace? We have to replace only lambda as infinity and lambda as 0, okay. Now see that I'm going to replace lambda as infinity. Now see here carefully, okay, we have e raised to minus lambda, okay, e raised to minus lambda divided by 1 plus x square. Okay, I'm going to replace infinity here. So see that only first step gives us the value for infinity. Okay, e raised to minus lambda can be written as 1 upon e raised to lambda and into 1 plus x square. So if I'm going to replace lambda as a infinity here, that means e raised to infinity gives us the entire denominator infinity, and 1 upon infinity it gives us the value 0. Okay, that means when we replace e raised to minus lambda as a infinity, this entire step goes to 0. So we have 2 by pi, take it out here, this step goes to 0. Okay, now replace lambda as a 0. Okay, that means e raised to 0 minus 0 means e raised to 0, which is a 1. Okay, minus, take the minus sign, infinity minus 0. Okay, so it is 1 upon 1 plus x square. Okay, yes, now minus sine x into 0. Okay, so we are going to replace lambda as a 0, sine 0 which is a 0, minus x, it is a keep as it is x. Okay, cos lambda, okay, cos 0 which is a 1. Okay, multiplied by 1, this one complete. So go for the solving. Next step, 2 by pi, next step we write here 2 by pi. Okay, under bracket minus 1 upon 1 plus x square multiplied by minus x. Okay, so we write x upon 1 plus x square, x upon 1 plus x square. This one is our required integral. Okay, f of x which is equal to 2 by pi x upon 1 plus x square. Now see that guys, this solution, it is one of the easier here. Okay, don't get confused, this is just the little confusion here for v, the value for v and value for x. Okay, I hope you all have cleared this confusion. So even after still, if you have any doubt, difficulty guys, let me know in my comment section. I will come up with the similar videos. Okay, so thank you everyone, thank you for my today's lecture.